Hello everyone, my name is Süleyman Efe Demirok. I'm currently a first year student in Department of Electrical and Electronics Engineering at Bilkent University. Today I would like to share the details of my Physics 102 individual laboratory project where I focused on the experimental application of Faraday's law of electromagnetic induction. Throughout this experiment, my goal was to observe how changing magnetic flux induced an electromotive force in a coil system. This is the experimental setup that I constructed for this project. As you can see, I have wound two coils around a plastic pipe to perform the primary and secondary coils. The primary coil is connected directly to an alternating current power supply, providing a time-varying and magnetic field. Meanwhile, the secondary coil is connected to digital multimeter, allowing me to accurately measure the voltage induced through the electromagnetic interaction. To ensure the accuracy of the induction, I carefully isolated the two coils from each other to prevent any direct electrical contact. This setup mimics the basic working principle of a transformer, which relies purely on magnetic conduction between coils. I conducted three main parts in this experiment. First, I gradually increased the input voltage and recorded the corresponding output voltage at the secondary coil. As predicted, the output voltage increased proportionally, demonstrating a strong linear relationship. Second, while keeping the input voltage constant, I varied the frequency of the AC power supply. It was observed that increasing the frequency slightly reduced the output voltage, which is consistent with the expected increase in inductive resistance. Finally, I tested the relationship between the number of the turns in the coils and the output voltage. My results confirmed that the output voltage was proportional to the turns ratio. Overall, the data supported the theoretical predictions with an experimental error of around 6%, which is acceptable for such a manual setup. Despite the following procedure carefully, some experimental errors were inevitable. Possible sources of error include the internal resistance of the copper wire, slight imperfections in the coil windings, and the magnetic flux leakage between the coils. Additionally, small fluctuations in the AC power supply could have influenced the consistency of the input current and the voltage readings. These factors collectively explain why the experimental results slightly deviated from the ideal theoretical values. According to the Faraday's law of electromagnetic induction, whenever the magnetic flux through the closed loop changes, an electromagnetic force is induced in the loop. In this setup, the alternating current flowing through the primary coil generates a changing magnetic field. This time, varying a field passes through the secondary coil and induces a voltage without any direct electrical connection. The amount of induced voltage is directly proportional to both of the rate of the change of the magnetic flux and the number of the turns in the secondary coil. This fundamental principle is the same mechanism behind the real-world electrical transformers used in the power systems.